I'll talk about language support for refactorability decay prevention. My name is David Lowens, and this work was done in the Department of Mathematics and Computer Science at the Open University of Israel, and it is a joint work with Dov Feivel. The activity of refactoring includes a lot of refactoring actions. Each refactoring action is a relatively simple restructuring of the code that doesn't change its behavior, but does fix some design issue in the code. Normally, a refactoring action is done in response to some code smells. This is with the intention of correcting the problem that caused or brought about those code smells. However, it is also used early on to make the code more robust, and if at all possible, prevent certain code smells from occurring. We call this kind of activity preventive refactoring, and the other kind of activity corrective refactoring. Now, the difference between preventive and corrective refactoring is not only when the activity is done, but also by whom. Preventive refactoring is normally done by the original developer, who's very familiar with the code, and therefore the cost of refactoring is low. On the other hand, it is difficult for the original developer to predict where code smells would occur, and therefore the return on investment is not guaranteed. In contrast, corrective refactoring is typically done by some other developer at a later point in the future. At that point, code smells already occurred, so the need for refactoring is certain, but the cost of refactoring is much higher. Two factors contribute to this high cost. First, the developer that eventually performs the refactoring is usually less familiar with the code. Secondly, the code itself evolves over time, and erosion takes its toll, making refactoring more complicated, sometimes too complicated for the developer that it just gives it all up. In this work, we present a different refactoring process in which the original developer just prepares the code for refactoring and annotates relevant segments. The actual refactoring action is done later by some other developer, and in the meantime, the annotation processor protects the annotated code against refactorability decay. Next, I want to show you examples of refactorability decay found in the JabRef open source project. This project deals with citations and references management, and therefore, in many places in the project, they need to check for balance brackets. What is surprising to find out is that this functionality is being re-implemented over and again rather than refactored and reused. And I'll show you just 3 examples on why refactoring is so difficult. There are 6 more examples in the paper, and in the code itself, you can find many more examples of checking balance brackets. The first example I'll show you is where the tool doesn't help you. So suppose you're looking for that functionality, and you discover the method convert special character, and you see inside the code a relevant piece that computes brace double, exactly what you need. And now you want to refactor, extract this code into a method. So you can right-click and get the context menu. You can choose refactor, but surprisingly, extract method is not even on the menu. And it's not here. And what's also interesting is that the tool doesn't even tell you what's wrong. Did you do something wrong? You don't have a clue on how to get beyond it. So you give up on this method and you look around and you find another method called check braces, promising name. You look inside and you find, again, code that deals with balanced brackets. This code maintains track of left and right brackets. Now suppose you want to extract this code into a method. Again, you can right-click, you can choose refactor. This time, extract method is one of the options, looks promising, but when you select it, the tool apologizes and says that it's unable to extract the method.
Okay.
This time around, it gives you a reason. It's because this code involves two values, left and right, and the method can only return a single value. I'll come back to this example at the end of the talk, but I just can just say that it's not that trivial to integrate those two variables into one, because they're also used elsewhere, not just in this selected code, but also in other places in the code. So you need to understand the code in order to fix it. So this method didn't work. You can try one last time, find a method called format name. This method also has code that computes a brace count. And again, you want to refactor, you want to extract this code into a method. This time around, the tool does the wrong thing. And different tools do different wrong things. If you try IntelliJ, it will allow you to refactor to offer you the option to extract method. If you do choose to extract it into the method, you will get your code in a method. However, because in the original code that you selected, not all control flows return a value, IntelliJ inserts a return false statement at the end of the method, which is not what you wanted. You wanted code that returns brace count. So it's not the right thing that you wanted. In fact, it just gave you back the original method. So you can try a different tool. For example, Eclipse, which also offers you a refactoring tool and offers you to extract method. Unlike IntelliJ, Eclipse issues a warning. It tells you semantics may not be preserved if you proceed. Now, if developers have nightmares, this is definitely one of them. You do have an option to proceed. If you are brave enough and proceed, the code will be extracted into a method. However, this method will not compile. And again, it has to do with the return value and the return type. So even such a simple functionality seems to be difficult to refactor if you don't understand too much about the code. Next, I want to show you the idea behind our approach, and I'll do that through showing you an example of how we deal with a specific refactoring action, move method. So the first observation is that move method, it's not really a one-click operation. When the developer needs to apply this refactoring action, it actually has to do a lot of things before and after, a series of steps. The developer needs to find a target class for the method. He needs to separate the method from the current class, maybe change its signature. If the signature changes, say, fixes the call to this method, then make sure that the behavior hasn't changed. Only then you can maybe use the tool to physically move the method to the target class, but then you have to also fix call to this method and eventually make sure that the behavior still hasn't changed. The second observation is that only some of these steps are sensitive to refactorability decay. We can identify the problematic steps. All the other steps, in principle, can be deferred and done at a later time with the same effort. The third observation is that for these three problematic steps, we can identify what properties in the code makes them difficult. For example, writing to an instance variable, or locking on the object, calling a private method, or overriding a method. These are the source of the difficulty in these three steps. Now, if the original developer is willing to eliminate those properties from the code, and then annotate the code with our movable method annotation so that no one else will reintroduce those properties to the code, then these steps too become simple enough that they can be deferred to a later time, and eventually the move method refactoring action can be done without any penalty, just as well as the original developer could have done. So this is the general idea behind the approach. In the paper, we explain the move method annotation with a list of properties. We also describe the extractable code annotation with a different set of properties that is relevant for that refactoring action, and movable code, which is roughly a combination of both of those. Finally, I want to show you how these annotations affect the refactoring process. And I'll show you two scenarios. The first scenario shows you that the annotations also help the original developer. Suppose the original developer identified a piece of code, which I showed you earlier, which could be potentially reused later on, and then annotates it as extractable code, indicating the beginning and the end of the relevant segment, and then compiles the code. The annotation processor will inform the original developer that there's a problem. You're using here two local variables. The point is that for the original developer, fixing this is easy. With a relatively simply fix, the original developer can combine those two variables into a single variable, in which case the annotation processor would be happy, and the code will eventually reach the developer that actually applies the refactoring action and will successfully extract the code, will even get automatically a very nice name. Everything works. The second scenario is what happens after the original developer annotates the code, fixes the problem. This is a different example, and passes the code on, but some developer, some maintainer along the way introduces new functionality into the code. This new functionality may introduce or violate those properties. In this case, the code will not compile. The annotation processor will indicate that there's a problem with the code that was added, which leaves the developer with three options: either fix annotations, or fix the code, or revert the changes. Once the code is recompiled without errors, then the process continues, and eventually it reaches the developer that needs to do the refactoring action, which will be able to successfully extract that method, that code into a method. In the paper, we also describe configurable annotations for experimentation and research. We talk about implementation strategies and our implementation. For evaluation, we discuss a user study we did, and we discuss related work. So, in conclusion, this work shows a different separation of refactoring concern, one in which the refactoring action is broken up into steps, and the responsibility for those steps is split into two roles. This also changes the refactoring process, because by distributing the cost of refactoring over time, it might encourage more refactorings than currently is done in the standard process. Finally, we hope that a disciplined use of our approach would be a step toward a refactoring-aware programming style. Thank you.
Thank you. Questions? Yes.
Yeah, thank you for the talk. I was wondering if the first developer that has to make these annotations has already did the work of mentally identifying which pieces of code he might want to move into a separate method. Why would he now just not directly extract it, but leave it up for a different developer if he's already done the work to make the part of the code extractable and he knows that this is a part of the code that should be extracted? But why would he then leave it within the original method?
That's a very good question. It's because the other steps do take effort. Now, if the original developer tries to refactor everything, it'll be too much work. And as I mentioned in the beginning, you don't know if it's worthwhile or not, because you don't know eventually if that will be needed along the way or not. So you want to do the minimal work necessary so that refactoring will remain easy to perform, but not overwhelm yourself with too much work in the beginning. So the annotation is, for the original developer, is not much more work than documentation. Usually what you see in code today is developers will write a lot of to-do statement. No, I know to do this needs to maybe refactor them, but they won't do it. They won't do it because it just they don't have the time for that. They don't have necessarily the need at that point for a lot of reasons. So the annotations are not much more than work, in our opinion, than documentation, but they do promise you that the rest of the work, somebody has to do it eventually. But if it has to be done, it will still work. Unlike what's happening today, that when you get to the point where you want to refactor, again, as I showed you, it's difficult because all those refactorability decay that occurs in the code.
But in your scenario, refactoring is automatic. I mean, you said Eclipse supports automatic refactoring if the code is refactoring ready, you know, to follow the advices produced by the tool. So it's not your scenario is not promising. I mean, because well, although you said refactoring takes cost, need a cost, but on the other hand, you're also saying that Eclipse IntelliJ automate that refactoring. So the only remaining thing is just to press a button to select the menu.
No, it's when you do the refactoring, pressing the button is one thing you do at some point, but you do a lot of steps before and after. And these steps are the ones that are difficult. The part, if everything else goes well, the part of just clicking and moving the method can be done automatically by tools. Also, some of the other steps, that there are some tool support to do them. But if the code has these properties that for each refactoring action, different properties, then you need to change the code. And usually you need to change the behavior of the code slightly. And this is difficult for someone who's not familiar with the code, regardless of how good your tool is. The person that is the best suited to consider and decide whether this small adaptation to the functionality is reasonable is the original developer. So the original developer, by annotating the code and taking care of any problems, does the hard work. I mean, doesn't do a lot of work, but does the work that requires deep understanding of the code and leaves all the hard work, but the more mechanical stuff to the person that eventually does the
Actually, I suppose a different answer from you. Because extracting method is not always a good thing. So that could be an answer. So at the beginning, well, the original developer may think, oh, this piece of code can be a separate method. But if I do that, the code will be excessively complex. So maybe I would like to I sometimes think that kind of thing. I want to postpone. If there I write another code and that needs the same functionality, then at that time I should extract that piece of code into a separate method. So in that sense, I think that, well, I basically agree to your approach, but I would like to say another kind of scenario.
Okay, I accept that answer as well.
Okay, any other questions? All right, then let's speak again.
Thank you.